Hi all, this is Andy from Moses Delay. This tutorial we will be creating a marketplace asset. I will be going through all the steps. I'm just going to create a regular blueprint, and the tutorials for it are going to be separated into 30 minutes. So I have a timer that will tell us when 30 minutes is up, and we'll see how far we get. So this is your regular project. A few considerations that need to be made for I suppose anything that you publish into Marketplace is that you want one folder. So we make one folder the same name as the project, so that when you import into a project, everything is nice and neat into the same folder. These files, however, they're from the test map, so I'll label that as a demo map, and I will move all of those folders into the demo map. Takes a while. And then I will fix up redirection in this folder that allows me to delete those empty folders. And I will move the demo map folder inside the other folder. Again, fix up redirection. It might not be needed. There you go. Instant. So we have the demo map. We have the demo map files. We have this is the structure of the third-person template project, so you should be familiar with it. I'm going to open up the blueprints that I need to play with. Third-person character. What else do we need to play with in here? We might as well bust into the mannequin for a second. Go into the mesh, export this, asset action, export. Get this out of the way right away. Onto the desktop. Sure, save it at that. Export. Okay, so this is going to be super simple, and I'm going to include it in the project so that we have a different mesh for the character to do some tricks with the camera. And this is Blender in 1080p, which I do not recommend but for the purpose of filming. So within the desktop we import the mannequin, open that up, and okay. So something went wrong there, not necessarily wrong, but it's too much work. So let's re-export that. And instead of selecting the yes, replace. Instead of selecting all of this stuff, I'm going to just export the preview mesh, which happens to be LOD0. And then when I import back into Blender, it will actually just be the mannequin with just one mesh, a little neater and easier to work with. Remove that. That leaves us with just the root and the mannequin, which is what we need. So tab into edit mode over here, and go into possibly that so that it doesn't look as bad. And let's do one for the front view and wireframe. Hold X to do that. And just drag and select, and then the plus button to select all the related. Delete the vertices, go into solid mode, and let's see what's left. So we have the neck that's left over apparently. I'm just going to click L while the cursor is over it. We do not want to remove that last piece. It's just this roundabout neck piece. Okay, and I think last final touch, because we are here and the way it is set up, is going to be to move that down in vertex mode. So we just want the little vertex. Best way to select this will be to rotate your camera from inside the body, look up into the sky like that, without the armature in the way, and that's the dot that we're interested in, so we can just see and select it, and then we can move that down on the Z and create a little better position for that on the mesh, so that it's not in the way whenever we decide to put the camera in there. Ideally, that's the end result. Okay, so with that done, I just, down at the bottom of Bone Breaker, export as either edges or faces. Let's try edges first. Let's see what happens. Desktop, we call this SK head less. Everything else should be default. Export and open it up. Import from the desktop headless. If there is any issues with the bone, it will tell me almost right away. I want to make sure that I'm using a physical asset that already exists. What is going on? Skeletal mesh, import mesh, import mesh. Oh, right. Unclick create physics asset. Select the mannequin's already existing asset so that we don't have to mess with that. Local, no, do not create materials, and no, not local. Search for all assets. Do not import textures. The rest should be okay. Compute weighted normals, that's fine. Okay, import, let's test it. Alright. That's that. That's the mesh without the head. Import it very nicely without a hitch, I would say. And now let's do the inverse for the head. So we go back here, we do edit, undo history, and edit, undo history, and we go back to the select more, and hopefully, yep. So in this case, I'm going to select the body area here, delete that, because that kind of clips the head out to what we need. And I know that this area here is the one we removed, but this one is not. So that one being part of the body, we leave it alone and delete that. Okay, and that's our head, neck included. And so we can go into wireframe mode, select all the vertices for it, and just to make sure that everything's selected, Control plus a couple of times. Then Control I to invert, delete vertices. Done. Go into solid mode. That's our head. Click edges to export onto the desktop. Headless. Just change that to head. And UE4 export. Done. File save. No, we don't need to save it. But let's import it before. Make sure everything's okay with that. Import the head. Okay, import. It is mostly okay. So there is that crease in the middle, which I don't think is visible on the main mannequin, but you know, for demonstration purposes here, that's hardly something we need to concern ourselves with. It'll be fine. You could join all the vertices between the two loops. Let me see if I can do that real quick. It should take 5 seconds. Mesh cleanup, merge by distance, remove 225 vertices, and double check that that's one. Look kind of weird, but yeah, it is merged. Okay. So with that being the case, select all, face, shade, smooth, and export. You can clearly see the line, so the line is still there. But that'll be that. Just export as faces because we shaded smooth into the desktop as SK head. Export. Go back to Unreal. You can actually this time around just open up the head and do a re-import base mesh, and that looks better, even though It's the shading, it's the smoothing group that kind of fixed it. Okay, so we're done with that. Save that out. We are already 10 minutes in, so let's keep moving. So we're gonna put that mesh into here and use those two meshes. So for the first one, I want to just replace the static mesh from here. I had that one selected, so use current one, should be okay. And then I add another mesh. Look at that, it's already set to headless. We just rename rather that to head, and then we select the proper head. Yeah, there we go. Okay, compile, save. The animation class is set to none, but it's set to use that. I'll set that to custom mode so that it's just a little cleaner. And within the construction script, which is somewhere over here, we'll take this mesh, we'll take this head, and set master pose component. So I just control click to move that. After that's done, we should have the viewport with the character patched up, but in two parts. So there you go. Now now let's focus on the rest of the tutorial. First of all, the head here needs to have a option set for the lighting to keep casting the shadow, the hidden shadow. So we'll trigger that manually right now, and that will be set. And that's how you decouple on head and keep it casting a shadow no matter what you do. Because we will hide and remove it to switch the camera into it later on. So with that done, go into the actual content folder, DynoCamera, and let's start creating the pieces that we will need throughout the tutorial. So we'll need an actor, and we'll call this BP external camera. We'll create another blueprint as actor, and we'll call this BP character camera. Then we need a blueprint interface, BPI camera management, MNGMT. And then we need another blueprint. Is it? Yeah, well, if I do a blueprint and then a scene component or actor component, and we'll call this AC for actor component. What do we call this? Camera operations. We'll open up this component, and class settings will implement the interface camera management. Compile, save. I'll delete those for now. We might need them later on, but with that done, we should see here. I did compile, right? And I did add the BP interface. Right, the BP interface has no functions yet. Let's save all. And within the BPI camera management, we'll create a couple of functions. So the first function is going to be external camera. Compile, save. And then the next one will be internal. So that tells us which camera to use. Let's also make another function, I think, for control. So we'll call this control rotation, and we'll define all of those later on. You can always change them, delete them, should be fine. For the external camera, we need a reference inside it. So we'll do actor, because it will be an actor reference that we need since we created actors to manage the camera. compile and save. For the internal camera, we might need to pass something back in, like an output or something later on. For the control rotation, obviously we need to output our rotation. And that can be set to a rotator, just like that. Compile and save. Now that those functions are created, we actually can double click this one because it's already implemented, and we can implement the function here and implement the function here, and this gets us started with that. So within the third person character, all of the stuff from the component, we need to make sure that's being used, and we need to do that by dragging the AC camera into it, and it will automatically just be a part of the character. So now everything that we do will be done inside this blueprint, but it takes place into the actor. So we have some level of control, and we can access the owner of within this blueprint to be able to communicate. So let's create the external camera first, and let's have a look at how that will work. So we have a default scene root, which we'll leave there, and we'll add a camera. We'll just leave it where it's at. We'll save. We'll add another component. We'll add a cone component, and we'll parent it to the camera so that it moves along. And we'll do some scaling of it. 10 10 10 as the base is probably okay, and then rotation on the Y by 90, I would say, and then just eyeball the amount that you are in front of the camera here. Okay, so as it is, this giant cone will be rendered in front of the camera. We want to make sure that we have hidden in-game available, and you can play with the other options here, like owner no see, maybe, and for sure we need the on begin overlap, but before we do that we probably need to set the collision to something correct. So we have block all dynamic. Now if you leave block all dynamic, you have set the camera trace and the camera visibility to block, which means that the camera will bug out and move because it's colliding. So can character step on? No. Custom from the overlap all, we'll leave it at word dynamic, and we'll change the visibility to ignore for camera and visibility, so that that is not an option anymore. Generate that, query enable, query collision enable query in physics. This can actually be changed to query only. Where is that query only? Right there. And scrolling down, now we can click on component begin overlap, and then go back into the viewport, select it again, component end overlap. So we have the two events. Now if I were to place this into a level, I should get the big cone, and there is nothing much that I can do to control what it does, because we haven't done the functionality for that yet. And you will also be able to rotate the roll, which might be something we need to prevent. So in order to do that, let's go into here, into the construction script. Let's drag the camera in, and with that we'll create a few variables for it. First, field of view. So we'll set the field of view. We'll make this one default 90, which matches whatever the field of view the camera is. And in an effort to keep things clean, I'll do a sequence, so that I can have multiple lines of quote-unquote code, and instead as nodes. So we'll promote this to a variable, and we'll call this f underscore FOV. Nice and short, and we can manage it. what happened there. Okay, compile and save. So we'll take another camera, copy and paste, we'll drag off, and we'll set the perspective, is it? You can always access the camera right there and it will tell you projection mode is what I was looking for. By default it is set to perspective. That's great. We just promote to variable. When we compile this variable, we will be set to perspective. We'll go E perspective, or we should really call it projection mode. Alright, compile, save. You can click it, make sure that it's set to the correct one. What do we have next? We need to make sure that the control rotation, use spawn control rotation, is set to a custom variable. Promote to a local variable. No, not a local variable. Promote to variable, and we'll call this one, hey, stop doing that. B underscore control rotation. After that, we need to set, so we set the field of view, we set the projection mode. What other options do we have on the camera that we want to control, that are on the camera itself? We have a constraint aspect ratio. That's a good one to enable. If you want to go into a purely cinematic camera, for instance, or make it look like it is. Connect the dots. Again, promote to variable. Call it B aspect ratio. Bring it down into place. Save it out. And now we need to start working on the cone a little. So for the cone, we need a local transform. Okay, so add local offset, that's good. That will allow us to move the cone up and down based on a transform. Really, we only need to manipulate one variable in here, but potentially you may want to change how the cone works. So we'll just cone offset B underscore cone offset. Nice and ordered. Good. And then for the cone we need to set scale. Promote this to a variable, and we'll call this B cone scale. Compile, save, align it. We'll bring it into the scene and play with it to see what it does. The other thing that we did not do, that we should do, is to reset the world rotation for the Z. How do we do that? That's for the all actor. Actor rotation. Starting to get a little jumbled up, so I'll add the reroute node, bring it down this way. Same thing here. Okay, so we're setting the rotation of the actor to our rotation that we are defining. And what was it in here that we were wanting to prevent is de-roll, and that's on the X rotation. So we'll negate the X by connecting in a, first of all, we need a boolean for it. B allow roll. Compile, save, make sure that this is set to false so that we don't do it by default. And then we do a branch, and then if this branch is true, we will not do anything. If this branch is false, like it is right now, because we're not allowing the roll, we will negate the rotation. To get the rotation, we'll just get after rotation. We'll split this up, we'll split this up, and just not connect the X. Compile, save, and we go back here. You see that the rotation has been reset, but that I can still change the other to, and the X also affects the proper but not the roll, which is what we wanted. So the camera is always sort of vertical. Looking nice. Okay, the cone itself is not displaying right now, and that was because of what we did with the, but we need to be able to see it in order to adjust it. So back into here, we will tweak off that rendering option for owner no see. Compile, save. I'm not in game mode, so why are we not seeing that? It has to be one of the options that we set for it. Construction script. So it's either this or this. I bet you the scale here is set to 0. Yep. So compile and save to set that default value to 0, and then the cone will be back here. Which also means that owner no see didn't really matter. Is it down? Is it up? Owner no see. So the camera itself, when you select the view, is not actually seeing it, even though it probably should. So that's what the hidden in game also does. So the cone, let's try to manipulate it with the variables that we have here for the actual blueprint. They're not exposed, so right, let's do that. So we'll set all of those variables that we created, we will set them into a category, and with 2 minutes to go, we're about to wrap this tutorial up, and we'll leave it at that. So if I click on here, it will expose all the variables. Compile and save. We are within the character blueprint, and now we have all the default values here. If I change the Z on here, I should be seeing changes of the cone on the Z axis, which is perfect, on the local Z axis. So perfect. If I scale this up to 100, then I need to move the cone away or further up as well. So that's why that's here. Good. That's all working. Save that. Last thing last, within the camera blueprint anyway. Clean it up a little, align things, compile, save. We want to create a category for those, and we'll call this management, and then just click and drag into it. You can actually sort the options as well. Say you want one to come before the other, like the offset of the cone. I care about it more than I care about the rest of the settings, so I can move it up. If only it would work right. Alright, compile, save. In the map, I get the options first now under management. Perfect. That wraps this portion up. Now, just to double check, I am able to walk into the cone or not. I am not. So let's go and look at that real quick. Make sure that we can and see why. Because query was disabled. It was query only, no physics collision. But the other options are set to block somehow. So let's set overlap to all and then go back and set visibility for the camera like that. And now we can walk into it. Good. See you in the next section.